Welcome to Lesson Overview 2.08, Volumes of a Cone. We are going to determine the surface area of the cone or sphere, explain how to derive the formula for volume of a cone, and solve problems involving the volume of a cone using the formula. A cone is a solid with a singular base, a vertex, and a curved line. Notice here you have two right cones and an oblique cone. The same thing applies with the volume of a pyramid as with a cone. You have the altitude or the height inside of a right cone and the altitude or the height outside of an oblique cone. The axis is inside of the right cone and the oblique cone. The axis and the height are the same on a right cone. Notice that the base of a cone is a circle. This is important when we're deriving the formula. The reason why is because as you make a pyramid bigger, giving it more sides, you notice that it turns into the shape of a cone, which gives us Cavalari's principle that the volume of a pyramid is equal to 1/3 the base times the height. But with a cone, the base is pi r squared because the base is a circle. Therefore, we can substitute b with pi r squared, and we get the volume of a cone is 1/3 pi r squared times the height. The altitude of a cone is AC. The radius is CB, or half of the diameter, and the axis in a right cone is AC, shown here. The altitude is AC, the radius is BC, and the axis is AC. In an oblique cone, the same thing applies. The altitude is on the outside of the cone, or the height. This is what we'll use in the formula, AB. The radius is CD, or DC, from the center of the cone to the outside edge, and the axis is on the inside of the cone, also known as the slant height of an oblique cone. Notice we're going to use that same formula, volume equals 1/3 base times height, where our base of a circle is pi r squared. We're going to go ahead and substitute the base as 9. Squaring 9 gives us 9 squared, and then multiplying that times the height, which is 14. Dividing that by 3 gives us 378. Pi for an exact volume, or multiplying this with our calculator's version of pi gives us an approximate value of 1,190. Here we're going to see that 15 is the base, or is the diameter of the base. We're going to have to divide this by 2 when we substitute it into our formula. Notice half of 15 is 7.5. So we're going to take 7.5 and square it, multiply that by 18, and then divide by 3, which gives us the volume of the cone, 337.5 pi as the exact volume. Multiplying our calculator's version of pi, we would get 1060 as the approximate value of pi. Now we're going to determine the exact volume of this cone. Notice the radius is 8 and the height is 15. We're going to plug in 8 for the radius. We're going to square 8. 8 eighths are 64, or 8 squared is 64. Multiply by the height of the cone, which is 15. Divide all of this right here by 3, and we get 320 pi, which is the volume of the cone. 320 pi centimeters cubed. Cubed means volume. Here we have an oblique cone, but this time we're not going to find the exact volume. We're going to use 3.14 as the value of pi. Therefore, we're going to take our diameter and find the radius. The diameter is 8 divided by 2 is 4. Therefore, our radius is 4 and our height on an oblique cone is on the outside. This is 10. We're going to plug in what we know. We're going to use our calculator's version. We're going to use 3.14 for pi. So we're going to say 3.14 times 4 squared, which is 16, times 10. Divide all of this by 3, and we get the approximate volume of the cone, which is 167.5 inches cubed. The surface area of a right cone is the sum of the lateral area of the base. So let's see how we might go about determining the formula of the surface area. Notice that the length of the arc of the shaded region is the circumference or the perimeter of the base of the cone. The formula for circumference is pi d, or 2 times r, which is diameter, d, times pi. The lateral surface area of a cone is similar to the area of the triangle, half times base times height, or 2 pi r, which is the base of a circle, divided by 2 times L, which simplifies to pi r L. Now that you know that the lateral area of a right cone is pi r L, all you need to do is to determine the surface area of the cone. Adding the area of the base is a circle, so the base is pi r squared. The surface area of a cone is S equals pi r L plus pi r squared. Before moving on, let's look at the idea from a slightly different perspective. Finding the surface area by finding the area of the base, which shouldn't be too complicated because the base of a cone is pi r squared. Finding the lateral surface area takes a little more work. If we were to unfold the surface area of a cone, it becomes a two-dimensional figure. As you saw in the fan-like figure, you unroll it. If you know the length of the arc, then you can use what you know about finding the area of the base to set up a proportion. Now, I'm not going to go through all of this because it's a little bit more complicated than we need in this video. I am, however, going to give you the link to the video where I explain this. So go ahead and pause and use that link to watch that video if you want to determine the surface area of the cone in more detail. Now that we know the surface area of the cone, we can say that S of a right cone with lateral area L and base area B is S equals L plus B. By replacing L with pi r L and B with pi r squared, the formula can also be written S, surface area, equals pi r L plus pi r squared. The figure shows a net of a cone here. What is the surface area of the cone? Where L is 20 and R is 5. Remember, a net is just the unfolded version of the 3D shape. And determine the surface area of this cone. We're going to take L, which is 20, and substitute it in our formula. We're going to take 5, the radius, and substitute it in our formula, both places. Now we've got pi times 5 times 20 plus 5 pi times 5 squared. Always do your exponents first. 5 squared is 25. And now we've got 100 pi plus 25 pi. When we add those together, we get 125 pi. Notice that this is the exact surface area of the cone. If you want the approximate version, you will use your calculator's version of pi, or you will multiply 125 times 3.14, which will give you the approximate volume of the cone. If you have any questions on this, please reach out via text or email.